Muscle as a result of the balance between diet and exercise. This is the topic that I'm going to discuss today. Uh, it's interesting to see that the muscle is a metabolically active organ that works not only to try to maintain a blood sugar balance, but also regulates the function of distant organs. On the other hand, the muscle is important for you to remain active to keep your functionality, especially as you age, because there is a phenomenon called sarcopenia in which you lose muscle just by aging. You can counteract this effect of muscle loss by doing exercise, specifically resistance exercise, and by adjusting the amount of protein that you take. Not all amino acids are created equal. You need to pay particular attention to the branch chain amino acids or BCAA, specifically leucine. So this episode focuses on this combination of nutrition and exercise, putting the muscle in the middle so that you can achieve a good functionality and metabolic health. I hope you enjoyed this episode and don't forget to follow me in my YouTube channel, Dr. E.F. Rain. You can also follow me in the different social networks, including Facebook and Instagram. Enjoy the episode. Welcome to Decoding Healthcare Research. I'm your host, Efrain Riveros, Dr. E.F. Rain. We have been discussing several aspects related to nutrition. Today, we are going to incorporate the variable of exercise, how these two play with each other to achieve the goals that we all want. The first thing that we need to determine is what is the reason the muscle is there. So is it just a scaffolding structure, or it has a function that can help us in different ways? Actually, the muscle has two main functions. One of them has to do with movement and functionality, and the other one is metabolic. The muscle is a metabolically active tissue that is able to regulate the response to insulin and the blood sugar concentration. In addition to that, it synthesizes molecules that have both paracrine and endocrine functions that can affect organs at a distance, like the adipose tissue, even the brain, when the muscle synthesizes a brain neurotrophic factor. So we see that this metabolic part or function of the muscle is critical. But let's focus for now on the functionality of the muscle. So the muscle is extremely important for you to be able to conduct your daily activities, to be able to maintain your functionality regardless of the age that you have. So the muscle needs to be trained for you to have a healthy life. So this is important. If you go along the spectrum beyond the daily activities, you can actually become like a professional athlete trying to maximize that functionality of the muscle. But for now, we are going to focus on regular people who do exercise in a recreational fashion. So let's start by recognizing that as we age, we lose some muscle mass, and this is called sarcopenia. There is an interesting study published by Lexel in 1988. He basically did some autopsies on different people who died of different causes. And he found that after 25 to 30 years of age, we started losing muscle. So this is important because even if you don't notice it, the sarcopenia is getting instituted from early ages. So the most important aspect then is to try to delay the loss of muscle mass from early ages. So how can we preserve the muscle then? Well, we have to understand that the muscle mass depends on a fine balance between the synthesis of proteins and the breakdown of proteins within the muscle. If you want to gain muscle mass, that balance has to be positive, and in case of sarcopenia, the balance becomes negative. So we need to understand better what factors determine the protein synthesis in the muscle as well as the protein breakdown. Let's start with the protein synthesis. First of all, we need to know that the source of amino acids to synthesize proteins in the muscle comes mostly from the diet. There are several amino acids that you can ingest in the form of proteins. When you ingest proteins, the first thing that happens is that in the stomach, by the interaction of chlorhydric acid and also the pepsin, there is an initial breakdown of those proteins, and in the small bowel there's going to be a complete degradation of those proteins by peptidases from the pancreas. The final result of this process is going to be dipeptides and amino acids. The amino acids can be absorbed by the intestinal wall, and actually the intestinal cell is able to capture those amino acids. Interestingly enough, approximately 40% of the total amount of amino acids in the diet is utilized by that epithelial cell of the gut. It is used for its own metabolic processes, including the production of energy. Then the rest of the amino acids can be absorbed and they can go via the portal circulation, they can go to the liver. In the liver, there is another process that leads to synthesis of proteins that are going to either remain in the liver or or they can be released into the circulation. That takes account of 10% of the total dietary intake of proteins. So we are left with only 50% of whatever amount of proteins we ingested. What happens with that 50%? Well, 40% of that is going to be utilized to produce urea. In addition to that, a small percentage can be used to synthesize neurotransmitters. So only 10 to 11% of the amino acids actually reach the muscle to stimulate protein synthesis in the muscle itself. So once those amino acids are available, they have the ability to stimulate the synthesis of proteins in the muscle. Actually, what has been demonstrated is that the transcription factors necessary to synthesize proteins are activated in response to the increase in the concentration of amino acids in plasma. But not all amino acids are created equal. Actually, there is a group of amino acids that is called the BCAA, or brain chain, or I'm sorry, branch chain amino acids. This BCAA can reach the muscle faster than the rest of the amino acids. The BCAAs are valine, leucine, and isoleucine. Out of those three, the leucine is particularly important because it's the one that leads the process of synthesis of proteins in the muscle. Research has shown that the activation of the complex of mTOR, or the target of rapamycin in the muscle, is actually the central molecule necessary to trigger this process. This complex ends up being a protein kinase that is able to phosphorylate different molecules and helps not only with the synthesis of proteins, but also with the expression of several receptors, including the insulin receptor, and it also helps with several anabolic functions within the muscle. In addition to that, the leucine is able to stimulate the AMPK, or kinase dependent on AMP, which stimulates the mitochondrial function in addition to the inhibition of the degradation of mitochondria. So it definitely helps with mitochondrial function that is necessary when you use the muscle for the different physiological actions. It's important also to remember that this same group of amino acids, or BCAA, can be used to produce energy. And again, the leucine becomes critical. These amino acids can only be found in the diet. You cannot find them, like you cannot synthesize them de novo in your organism. This is important. So we need to know where to find this type of amino acids. They can be found in beef, in chicken, dairy products as well, and in a lesser in a lower amount, they can also be found in soybeans and some vegetables. There is an interesting study published in Nature that evaluated the content of amino acids in different foods, and they found, as you can see in the picture, that the leucine is more prevalent in animal products. And when you analyze this from the diet standpoint, you see that carnivore diets and ketogenic diets have more leucine compared to vegan diets. And there are some types of diets along the spectrum with different amounts of leucine, as you guys can see here. So it's important to know then that leucine stimulates the synthesis of proteins in the muscle. And there is actually a temporal sequence that can be observed once you have a meal rich in proteins. There is an initial increase in protein synthesis by the muscle approximately 30 minutes after you had your meal. It peaks at around 2 hours, and it returns to baseline in approximately 3 hours. So you have a window of opportunity between 2 and 3 hours to actually increase your protein synthesis in the muscle and generate some muscle volume and hypertrophy. So if you are interested in not losing muscle, it would be probably a good idea to take some protein right after you do exercise, because if you don't do exercise, you miss that window of opportunity of protein synthesis. If you want to maximize the production of proteins and the production of muscle, you should combine exercise with these protein meals, specifically those rich in BCAAs and specifically those that are rich in leucine. So it's interesting to notice that when it comes to synthesis of proteins in the muscle, Moore in 2015 was able to determine that for young people with 0.24 grams per kilogram of proteins, you maximize the amount of proteins that you can synthesize in the muscle. For the older people, you need 0.4 grams per kilo, 68% more. So this is the second message that I want to leave here. If you belong to the older generations, you need a higher consumption of protein, specifically leucine, so that you can able to maximize the synthesis of proteins. This is really interesting. Actually, what we see is that as you age, your machinery to synthesize protein is actually normal. What changes is the ability or the threshold better to stimulate the protein synthesis, and you can compensate for that change in threshold by increasing the amount of proteins that you consume. Um, what is recommended is that you either consume 20 grams of protein per meal if you are not doing exercise, because with that you can achieve a baseline level of protein synthesis within the muscle. But if you are doing exercise, the recommendation would be to take 40 grams per meal, and you can do that every 6 hours. That means 3 times a day while you are awake. So 40 grams 3 times a day is probably the recommended dose. There is an interesting study performed actually by a couple of authors in 2015. Moore was one of them, that demonstrated that if you are not doing exercise with 20 grams, you achieve the maximum synthesis of proteins in the muscle, and you don't gain additional synthesis by increasing the dose of amino acids. However, if you do exercise, it's interesting how in the graph the amount or the level of protein synthesis by the muscle actually increases if you give more protein for 40 grams per day. I'm sorry, per meal. So that's the recommended dose if you are doing exercise. So all this has been analyzed during the time that you are awake. And in the past decade, a growing interest has emerged regarding the role of proteins when you are sleeping. So actually, there is an author, his name is Dr. Broin. He evaluated exactly that. What is the effect on protein synthesis if you provide a load of amino acids before you go to sleep? And he found that 22% of the protein synthesis can be increased if you get the protein right before you go to sleep. What type of protein? Casein protein is better than whey protein for that effect. Why is this so? Because casein is long lasting, so that compared to whey protein provides a benefit to increase protein synthesis while you sleep. So if you are in the process of gaining muscle, a good idea would be to consume 40 grams of protein per meal 3 times a day, in addition to a dose of casein before you go to sleep. This naturally has to be accompanied by exercise. Everything that I have mentioned so far is focused on protein synthesis. But what about protein breakdown? It's interesting to see that as you increase the protein in the diet, the breakdown of protein is also affected. It's actually suppressed. So it would seem to be a good idea to maintain a super high dose of protein so that the breakdown is blocked and the amount of protein in the muscle increases. However, suppressing the breakdown of proteins is not actually a good idea, because you need this renewal of muscle. When you do exercise, there is some fiber damage, and that damaged fiber needs to be replaced. So you need the synthesis of new proteins, because some of the old proteins of the damaged fibers are actually defective. You need to clear them uh, via the different mechanisms that the muscle has, including the activation of the proteasome. So it's probably not necessary for you to go to the higher limit of proteins, like 60 grams of protein per meal. That's too much, and it leads to suppression of the breakdown of proteins that apparently is not that healthy. So we talked about the effect of different amino acids, specifically BCAAs. to stimulate protein synthesis in the muscle, but it's not the only stimulus that is necessary. Insulin, which is an anabolic hormone, also stimulates the synthesis of proteins in the muscle. The interesting thing here is that you need just a low dose of or a low concentration of insulin to achieve that end. You need approximately 5 units per ml of concentration to achieve that goal. And if you go beyond that, the effect is not necessarily better. That means that you should keep a relatively low level of insulin, and that should be sufficient to maintain the synthesis of proteins. So the use of carbohydrates when you do exercise, even though they are not critical or completely necessary for the synthesis of protein, you still need a small dose of carbohydrates in order to replenish the stores of glycogen that you may have lost during exercise. Everything I have mentioned so far refers to an individual who is doing exercise and is actually having the regular meals. However, there is a percentage of people who embark themselves in caloric restriction. So what happens when you restrict your calories? The caloric restriction per se inhibits the synthesis of proteins by the muscle, and this makes sense because the synthesis of proteins by the muscle is an energy consuming process. So if you need to save energy, you need to try to block the synthesis of proteins. And this is not a good thing when you are embarking yourself in a diet, because you are restricting calories, losing weight, but the weight lost tends to be at least 27% due to a loss of muscle mass. You need to avoid this. How can you counteract this effect of muscle wasting with caloric restriction? You can do that with two strategies. The first one is with the use of exercise, specifically resistance exercise, because this type of exercise stimulates the synthesis of proteins. But that's not sufficient. You also need to increase the intake of proteins, specifically leucine. You need to make sure to consume at least 2 grams of leucine per day. You need, if you are doing exercise, if you are restricting your calories, doing exercise as well, you probably need to be around 2 to 2.4 grams per kilo of protein so that you don't lose muscle. And this is probably the recommendation. In addition to this, we have to remember that when you consume a high amount of proteins, there is a better suppression of appetite. So how does this occur? Well, the first thing that happens is that the amino acids are able to inhibit the dipeptidyl peptidase 4 enzyme that is in charge of degrading the GLP-1 or glucagon-like peptide type 1. When you don't degrade this GLP-1, the GLP-1 is able to go to the hypothalamus and inhibits the appetite. So you have a satiety signal all the time. There is another mechanism to suppress the appetite by amino acids, and is mediated by cholecystokinin. So, what are the recommendations then? To summarize, if you are doing caloric restriction, do resistance exercise and get at least 20 grams per meal of protein, ideally 40 grams per meal, 3 times a day. And don't forget to get a supplement of casein right before you go to sleep to try to increase the synthesis of proteins overnight. So this is a good recommendation. Naturally, if you have like a kidney disease or any condition that can limit the amount of proteins that you can take, don't forget to always get the advice of a physician. It's also important to remember to always be on the high side of the protein intake so that the synthesis of protein by the muscle is maximized. Finally, I want to make a couple of comments regarding the sarcopenia that happens with aging. So, as I mentioned before, the problem is not so much that the metabolic machinery of the muscle is not working. The real problem is that the response of this machinery to the amino acids is not the best. So, you need to compensate that by increasing the amount of protein and also by doing exercise. Again, the consumption of leucine should be at least 2 grams per day in a balanced diet. Where can we find the leucine and the BCAAs? We can find them, and as I mentioned before, this is a reminder, you can find them in beef, eggs, dairy, some vegetables, but in general terms, vegetables tend to fall short when it comes to BCAAs. So this is, in a nutshell, a summary of what happens with the muscle. How can you maximize the synthesis of proteins to maintain and improve the muscle volume and also function, so that you can remain functional and even move along the spectrum of muscle hypertrophy. I hope this information is useful, and see you in the next episode.